Hello everyone. I hope all of you are doing good and you remember what we are discussing. We are discussing the chapter motion. Okay. In our last class we have derived the relation. What was the relation? The equations of motion. First relation we derived. The first relation that we derived was in our previous class. It is V equals to U plus AT. This formula was derived in our last class. Okay. Now, in this particular formula or the relation, V is what? V is the final velocity. Okay? If a car is moving, after a certain time it will be certain velocity or not. It is the final effect take. And what is U here? U is the initial velocity. Okay? V is final, U is initial velocity. What is A? A is acceleration. Okay, and what is T? T is the time in which the object has or the body has changed the velocity. So this is the last topic that we have discussed, and based on this topic I have given you one or two numericals also. It is done. So for today's class what we will do, we will derive the next relation. What is the next relation? Next relation is relation between distance and what? Acceleration or distance and time. Okay. We are going to derive the relation. The relation is, I will write, relation is S equal to, this is the relation that we are going to do, UT plus half of AT square. Okay. So we are going to derive this relation. What is the S here? S is the distance, U is the initial velocity, T is the time, A is acceleration, and T is again time. Okay. So in our syllabus, we have to derive this relation using graphical method. So how to use graph to solve this, to derive this? So for this, let us consider a graph for velocity and time. So we will draw a graph like this. So this is time axis. I am writing T and it is in seconds suppose. And this one is the velocity axis. It is represented by V. What is the unit? Unit is meter per second. Okay, done. Now what we will do for the derivation? For derivation, we will consider a uniformly accelerated motion. Uniformly accelerated motion means it will be a straight line, but it will not be parallel to time axis, but it will make an angle. Moreover, what is the second condition I will take? I will take that the initial velocity is not zero. The object will not start from zero. Okay. So what we will consider? We will consider that the object is at certain. Suppose you have started your journey from home. When you have started your journey from home, what happened? As you are moving in your car, suppose this is your home and you have started your journey. Suppose I am drawing roughly. This is just a rough diagram. And you have started your journey. Initially it is U is equals to 0. Here velocity is 0. Then you move to this particular point. Okay. This particular point. And the time is, suppose I consider the time here is 0 now. This one already the object or the vehicle is in motion or not. So it has a particular velocity. That one I will consider it to be the initial velocity. And after it has traveled for certain time. Suppose I say for t time it has reached here, the velocity become v. It's okay. Now here this u is 0, but this is my initial or not. I will consider this to be u. So if I plot this one, I will get a graph not from the origin but from little bit above here. It's okay. So when I will draw, it is since it is uniformly accelerated, so I have to draw a graph like this. I hope you have understood how I have drawn. Because the last derivation also we have derived in the same way. At this particular point, let us consider this to be A and this velocity to be initial velocity u. When it reaches this particular point, this is my point B. Suppose, what is the velocity? How to calculate the velocity if I give you a graph? In graph you have studied, I think. So you will draw a perpendicular here and this particular value will give us the velocity at that particular point. So let us consider this velocity to be v. Now what is the time? So what we will do, again I will draw a perpendicular here and that perpendicular is touching which axis? Time axis or not? Since it is touching time axis, So this particular value, if it is 5 second, 5 second, 5 hour, 5 hour, 3 minutes, 3 minutes, whatever, that will be the time for which the object or the vehicle is in motion. Means from here to here, what is the time? T is the time or not? So from here to here I have drawn, no doubt in this way. At this particular point, what is it? It is touching? It is touching the time axis. So this T will be T. I hope it is clear. Now, in order to find out this particular relation, do you remember I have taught you that if it is a velocity time graph, the area under graph will give us the what? It will give us the displacement of the particle. Okay. Now, if I find the area under the graph doesn't mean these dotted lines. What is this? Our graph? Our graph is from A to B. So area will be this one or not? This entire part? This area? So this area, if I can calculate, then I will get what? The displacement of the particle or displacement of the vehicle. So how to find out this displacement? In order to derive this relation, we have to draw one perpendicular from here at this particular point. Suppose this is my C, this particular point to be D. Okay, what I will write here, displacement. If you want to write displacement, I have written here velocity, so I am writing the term displacement. Suppose you have written speed, write the term distance forward. So that is the difference between distance and displacement. So displacement equals to area under, what is the rule? VT graph. I hope everyone have understood the previous topic. So this is my topic, this is the previous concept. Now, if I say area under this, can I write this as area of? See now, if I want to calculate the entire area, I can think of the area of this triangle plus area of this rectangle. Will I get the area under the graph? Okay, so I will write area of triangle ABC plus area of what? Rectangle. I am writing the rectangle like this. I am not writing the full spelling. Rectangle, I will write OACD. Now what is area of ABC? If it is a triangle, we used to find our area by half into base into altitude. What is half I have written? What is the base in this particular triangle? Base is AC. What is the perpendicular? Perpendicular is BC. So this is the area of what? Triangle. Now what is the area of this particular part? Area will be, rectangle is what? Length into breadth. Length I will consider OD into breadth means OA. It's clear, I think all of you have understood. Okay, if you have understood this particular concept, now from the figure, if I ask you from figure, what is the value of OA? Can you tell me? OA, if I ask you what is the value of OA? OA is what? From here to here, what we are plotting? We are plotting velocity. So OA means what? U or not? OA is equals to U. Since I have drawn this perpendicular, so and these two lines are parallel, so CD will also be what? U or not? CD will also be U. Similarly, if I ask you what is BC, which one is BC? This is BC. Okay, BC. How can I write BC? I don't know about BC. But can I write BC is equals to BD, this entire, minus this? So I will write BC is equals to BD minus CD. Now what is BD? BD means from here to here. So from here to here, if I want to measure, this will be what? V or not? V. So it will become V minus, what is CD? We have already written CD is equals to V minus U. It is okay, we have got this. Another term, what is OD now? OD. OD is what? Time T or not? So I will write OD equals to small t. So these are the things that we got from what? From the figure. So from figure we have written this. This is the concept that we have got from the previous knowledge. So we got the relation. Now next comes, after this what we will do, we will substitute these things here. Okay, since maybe, so when I will substitute this, I can write, I will rub this part. So therefore, displacement I will write S. Therefore, S is equals to half than half. AC means we have written AC is what? Where is AC? AC. Okay. OD is equals to AC is equals to what? T. So into T will come. Into then BC. What is BC? BC means B minus U. So it is B minus U. Plus, this is length into breadth. OD. OD is T. Cross multiplied by, what is the other term? OA. OA is U. Can I write this equation as UT plus half of V minus U into T? Yes, we can write like this also. So if we write like this, now since V minus U is equals to AT, our previous derivation. So if I substitute it here, what I will get? S equals to UT plus half of V minus U means AT into, again T is there or not? So T. So what will be my relation then? S will become UT plus half of AT square. So this is the relation for what? Distance and velocity, position and what? Velocity or position and time. So we got this relation. What is the relation? S equals to UT plus half of AT square. How we got it? We got it with the help of graphical representation. What type of graph we have plotted? We have plotted a graph for what? Velocity and time. No doubt I have plotted for velocity and time, but what is the condition? Condition is uniformly accelerated motion. What is the next condition along with uniformly accelerated? The second condition is that the velocity we have not started from 0. The velocity we have started from a certain value. Okay, hope you have understood. Next we are going to derive the next relation. Thank you.